Okay, so hello everyone, my name is Vikash and today we are going to solve the D4, which is Codeforces Round 1074. So let's start with the first question, which was perfect root. It was like a very easy question. So in this question, let's say in this we have given a perfect integer x, sorry, a positive integer x, which is a perfect root if there exists an integer y such that the root of y becomes x. So for example, 5 is a perfect root because root 25 is equal to 5. And for each test case, we have to print the n distinct perfect roots, right? So that's all we have to do. So, but let's say which elements are perfect roots, which elements are perfect roots. Perfect roots. Let's try to analyze this thing. Is one perfect root? Yes, because I can write it as the square root of 1. What about 2? I can write it as the square root of 4. For 3, I can write it as the square root of 9. So that's it. Every number, every number is the perfect root in our case. So that was it. So there was nothing in the question, nothing in this line, right? Because we know that every number was the perfect root, so we just have to print any and distinct number we like. Okay, so that's what I did in this case. I just took the input and then I just printed all numbers from 1 to n because they are distinct. That's it. So if I run this, like you know that for this n equal to 5, what I print is this 1 2 3 4 5, and I know that all of them are the perfect root, and of course all of them are going to be distinct one. So I guess that was it from the first question. It was like pretty easy one, and like mostly everyone solved this. Now let we move to the second question, which is the prefix max. So in this question, we are given an array of n integers, and the value of an array is the sum of the maximum of each prefix of the array, right? So the value is the sum of the maximum of the each prefix of the array. So like what do we mean by the prefix in this case? Let's take the question B, problem B. Okay, and let's say we have some array like let's say this thing. Okay, now what is the prefix? So prefix is just the sub array which is starting from this first element, right? So you can say this 1 2 is a prefix of this array. This 1 2 5 4 is the prefix of this array. This only one is also the prefix. So that's it. Let's write all of the prefix. So 1, then 1 2 1 2 5 1 2 5 4 and 1 2 5 4 and 3. These are all the prefix. Now we know that the value is the maximum, the sum of the maximum of each prefix. So let's say what is the maximum of this. So the maximum for this element is 1, the maximum of this element is 2, the maximum of this element is 5. For this prefix, sorry, the maximum of this prefix is 5. The maximum of this prefix is 5. And in this case also again 5. So now my value is going to be the sum of all elements, which is this thing plus 5. Okay. But what else I can do? I can choose any two indices and the swap two elements. And I can do this operation at most one time. So I can just choose any two element and swap them. And after doing this, I have to find the maximum possible value of the array. What is the maximum value of this array A? Okay, so now in this, we have to maximize this sum, maximize the sum. So therefore, we will try to maximize all of them, all of this value, right? So we have to do something like some swap operation such that the value increases. So let's say what if we try to increase this prefix? Okay. uh, so we can do something like I took this 3 and this one and swap these two elements. I can do this 5 and this one and swap these two elements. But in this, like the observation is that the observation in this case was that the first element comes in all of the prefix, right? So the first element sorry, mm, contributes in maximum for all prefix for all prefix. Is that clear? Like you can see that this one, this is the one which is the first element, come in this first prefix, also come in the second, third, fourth, and fifth. This comes in all prefix. So now if I just take this maximum value and put it here, I know that the for all of the element, the maximum is going to be this thing, right? So if I just swap this and this element, now I know that this thing is going to be 5 for all of this, and this thing is going to be 1 now. So I know that now my maximum is 5. So that was it. Now the value is 5 plus 5 plus 5 this times. Okay. So now in this case, this is the maximum possible answer we got, which is just the maximum element in the array into the maximum element in the array into number of prefixes. This thing in our case is just nothing but the size of the array. So yeah, the answer is now is going to be this maximum element into size of the array, and we just have to do this thing only. So what we do is we just take the input, take the vector, and then find the maximum element, and the answer is just this maximum element into and just print this answer. Yeah, so that was very easy thing. Now let's move to the hard question. So it was slightly tougher than this A and B. In this question, the name is if did max. So in this question, we are given an array of n integers, and what we are allowed to do is to perform some operation, this operation only once. What we can do is select an integer x, and for each value I, we add this x in all of the elements of the array, right? And for example, if a is this and x is this, then I will add 3 in all of these elements. So this thing will now be 1 plus 3 is equal to 4, this thing will be 3 plus 3 is equal to 6, and so on. And we have to output the maximum possible value of this MEX of the array after this operation is performed. Okay. So let's try to reduce this question, or like what if let's try this for simpler case. What if we have only one element? We have only one element. Like ARR is like 4. So what should we do in this case such that the MEX becomes the maximum, right? So like in this case, the MEX which is 0. because 0 is the maximum, 0 is the minimum positive integer which is not in this array, right? So what I can do is just I take x is equal to -4, and now my array is equal to 4 minus 4, which is 0, and now my mex is equal to 1. So what I did in this case, what I did is it's like there was some like range, let's say 0, 1, 2, 3, 4. I have this 0, or I have this element at this 4, and in one operation I have shifted it to this 0, to the 0, and the mex is just the next element which is not present in, or which is not taken in this segment, right? You can think of something like this. I have just shifted this thing to here. That's what I did, and now my mex increased by 1. Okay, let's see for some other case. What if we have some range of elements, like ARR is like 4, 5, 6? What we will do in this case? So again, we can what we can do is take the x is equal to -4. Now my array would be 0, 1, and 2, and now my mex would be 3 in this case, right? So what we did in this, we have this big line of some, we have the, let's say this is 4, this thing is 5, and this thing is 6. So I have shifted this 3 thing to this 0. Let's say this is 0, 1, and 2. This thing is 4, this 3, 5, and 6. So I shifted it to here, right? And now my mex is nothing but the next element of this. So can everyone understand this, right? So if I have this continuous range, I will shift it to the 0, and now my mex would be like the next element which is not present in this thing. Okay, but we have some like random numbers. Now I think we have some of the observation, and we can think for the random numbers. Like some array is something like 2, 3, then 50, 51, 52. What we can do in this case? So what we can do is we have, can you see that in this case we have two continuous shifted to the 0. So now this 2 will become 0, and this 3 will become 1, and the mex will have, I will have is 2. Like, can everyone understand this thing? Now, what if I just take this continuous segment? I just see about this continuous segment. So what I can do is I just do -50 in this. So now this thing will become 0, this thing will become 1, this thing will become 2, and then the mex will become 3. What about this continuous segment of only size 1? So if I have this continuous segment of size 1, I know that I will just make this 100 as the 0, and then mex I will get is 1, right? Okay, let's take this by an example. Okay, I take x is equal to -2, then my array will be 0, 1, 48, 49, and 50, and 98. So I can see here that this is 0, 1, and my mex would be 2 in this case. So can you take the observation now? The observation is that the answer is the maximum size from all of the from all of the continuous range, right? So that's it, and that's all we have to do in this case. the the answer would be the max size of all of the continuous segments. So we have to go for all the continuous range and then find the what is the size of it. What is the size of it? That's it. So let's see in the code what we do. So I have just taken the input, the n and the array, then sorted this thing, and now this is a very fundamental thing. What I do in this thing is, so what is this current and answer? So let me visualize this thing. Okay, so let's say we are finding the answer for this thing. Okay, so here my current would be size of the current segment. Current, no segment, continuous segment, continuous segment, right? And the answer is just the answer. Okay, so I will come here and I have to find all the continuous segments. So I just start at this 2, and then I will say that can I go at this 3? Yeah, so this is the continuous thing. So my current will be now 2 in this case. Now I will say that can I take this 50 also in my this range? I cannot take this 50. So I will break this here, and now I will store it in the answer. So now this thing I will do that, yeah, this answer can be this thing. Okay, and now I have seen for this continuous range. I will now move to the next range. Okay, now my range will start from this 50. My current will be now 1. Then I will check, can I go to this 51? I will say yes, I can go to this 51, and now my range size would be 2. Then I can go to this 52, my size would be 3. Then can I go to this 100? I cannot go. Then again I do this operation, and now current is equal to 1 again, and now everything is completed. So I will just do this operation, and that's it. So that's all we have to do in this case. Let's see what is the code. So we have just taken the input, sorted the elements and the answer, and this is the current size of my continuous segment. I run a loop. Okay, now I check. So if this is the same element as the previous one, I don't care about this. Okay, so we just continue in this thing. I don't have to think about this element. Else, if this ARR is equal to ARR of I minus 1 plus 1, means that this ARR of I is in the continuous range. So I just do my size plus plus. Else I have to break the loop. So I just do this operation, and now my current is equal to 1. And in last also I do this operation, and then just print the answer. That was it according to we talked here, right? Okay, so I hope that everyone understood this question. Now the some of the good questions will come. Okay, now we will see about this question, the question D. Hmm. Okay, just give me like 10 seconds. I will be back in after drinking the water. So let's read the question. The name of the question is out of the memory error, and in this we have n integers, and the best he perform n of m operation on the array. In ith operation is that he takes the bith element, he takes some element and then add the value ci in this element. That's it. And Unfortunately, due to rising RAM cost, Bessie's computer has a limited memory, and whenever any element of the array is greater than h, her computer crashes and every element in the array is reset to the original value. Okay, and we have to output the array A after all of the operations, right? So how do we think in this case? Let's take some test case and try to think about it. The constraints are all of the are like 1e5, so I have to think something about O of n or n log n. Okay, so this is my test case. The array I have is this 1 to 1, this is n, this is m, number of queries I have, and this is the h, this is the limit, right? This is the limit. So let's say overflow limit. So we have 1 to 1 in initial condition. Now I update this thing. So I go at the first element. I go at the first element and add 4 into this. So this element would be now 5. So this thing is in the limit, right? This thing is not greater than this limit. So that's okay. Overflow will not occur. And then I do the second query, which is this. So I go at the second element and add 4 into this. So now my element would be 6. And the 6 is greater than this 5, so the overflow will occur and my all of the values would be reset to this original position. So now this thing will be like just 1 to 1 again, and now I will do operation from here, right? So will the brute force work in this case? Will the brute force work? So like for the reset thing, I have to iterate all elements. So the time complexity is going to be O of n per query, right? Because I am iterating all element to reset this thing. And if this is the case, my time complexity would be O of n into q, and this thing will give us TLE. So we have to find some way. We have to find some way that we don't have to iterate all element and reset this. Like, can you understand this thing? So we have to do something that we don't have to do this reset thing on all of the elements. What we can do? So this is like the fundamental thing or something. The observation is that we will be as lazy as possible, as lazy as possible, or we will update the element only when I have to access it, right? I have to access it. That's it. I will not update all of the elements when I have to do this reset query. I will be like, I will stop for a second. I will not reset in any of the other element, and then only when there is some work of some element, I will update this only then. Like what I mean to say is that, like say, okay, let's say I do this, I have this 1 to 1, I do this first query, and now this is 5, this 2, 4, and this thing becomes 6. And now I have to reset this whole thing. But I will not reset this whole thing. I will just reset this thing and this all the other element. I will stop. I will like store somewhere that I have to reset them. I have to reset them. But I will not reset it currently, right? Reset it currently. So when I am going to reset this value or when I'm going to modify this value, okay. So assume that I just did the second query and I just resetted this thing. Now I come to this 3 3. Okay, and of course I have to modify this value. So I come at this thing and I found that this one is the older value. This is the older value, right? This is not modified value. So I will have somewhere stored that this is the older value, not modified value, and I have work of this. So then only I will delete this element and reset it, and then only do my queries. The queries, and then only I do will this thing. Okay. Now let's see what I mean to say is that let's say I have this one, two. Okay, this query now. I have done these queries and I am at this query right now. So I will go at this 5. I will ask it. I will somewhere store or something. I will ask that when was the last time? When was the last time this element was modified? Modified. And when was the last time I did the reset operation? Reset operation. Okay. So I will ask these two things. And now if I know that this thing, the last time I modified is much older than this thing, then I know that I have to reset these things. I will reset this to the original value and then only I will perform my this query. So that everything. Oh, that's all. This was the logic, right? This was the logic that I will be as lazy as I can. I can. So that's it. So that's all of it. Now let's see the code currently. Okay. So this is the code, and what I was talking about this data structure. Okay, I was talking about this data structure that I will ask that when was the last time this element was modified, right? Right. Oh, just a second. There is a grammar issue. Sorry. Okay, I will ask that. So I can easily store this thing. Okay, so what I will do is I will have some vector of vector. Sorry, vector of vector this well, which stores nothing but this thing value and the last modified time. So that's it. Okay, and this reset variable is nothing but to store that when was the last time I did the reset operation. Then I run in this loop. I take the input, and because I work in the zero based indexing, I do this index minus minus. So what is this val of index of 1? This is just last time I modified this value, and val of end of 0 is going to be the current value for the ith element, right? Ith element. This is it. Now I will ask him that, hey, what was the last time that you have modified it? And if this thing is older than this reset, then I know that I have to do reset. So I will do this reset operation. Then I will do this update query. And then I have to check. I have to check if this value is overflowed or not. And if this is overflowed, then again I will do this reset operation and change this value. And now this thing is now the last time I modified this value for this ender is now ith query, right? Is the ith, and then I just print these values. That was it. That was it in the fourth question. And now we will come to the some harder question, right? So like let's see the number of problems solved from a person solved this question. So these are now pretty hard. So if you were not able to solve this question, that's okay. But let's move to this robotic rush. Yeah. So in this question, there exists an infinitely long number line, and on the number line, there are n robots and m spikes, each located at some specific point, and the ith robot is located at the point AI, and the ith spike is located at the point BI. And if a robot touches the spike, it dies. Okay. And now there are k instructions that are transmitted into the robots, with each instruction being to either move to the left by 1 unit or move to the right by 1 unit. And then for each value, for each value till k, I have to output that how many robots are still alive after the first I instructions have been processed, or all the I instruction have been processed. So in this question, like we will have some, let's just see this by some test case. And in this, we will have some infinite grid. And on this grid, let's say this grid is something like this. And on this grid, there are some robots on some points, and also some spikes, which are something like this. Okay, so these are the spikes. And now in the instruction, we have to given the L or R, and now we will know that in which direction we have to move. So just assume that some instruction is like LLR. So now what will happen in this case? So the first instruction is L. So all of the robot will move to 1 unit left. Will move to 1 unit left. Okay. So now this robot has now touched this spike and it is died. Okay. This robot, there is no spike and there is no spike. So what can I say is that after the first instruction, two robots are alive. Two robots are alive. Okay. Then we just see about. Okay, so we just remove this robot. Okay. Now the second instruction will come, and all of the robot will now again move to one stop left. And this robot has now come to on a spike. So he will also die. Okay, so now this robot has also died, so we will just remove this robot, but this robot is still there. So we can say that after the second instruction, one robot is alive, and we have to find this for all of the instruction and give the and print this value, right? Print this value from this. Okay, how can we do this operation? Can we do the brute force approach? So of course we cannot do the brute force approach, because like for each instruction I have to move all of the robots. So the time complexity of this, so for the brute force approach, the time complexity is going to be like O of, O of Q into N, where Q is the number of instructions and N is the number of robots, right? So now we have to find some way to reduce this thing. We cannot use the brute force. So now we saw that we cannot iterate according to this instruction value, but can we iterate according to this robot? Okay, now the question is, can we find when this ith robot died? Because let us say that this robot died on time x, right? Then for all time less than x, it is alive. It is alive means it contributed in answers for all elements for all time less than t. So can you understand this? So now the question is about finding that when this ith robot died. So let's try to analyze some test case and see if we can find when the ith robot have died. Okay, so let's have some robot and make this infinite grid, and in this grid there is the robot somewhere, and the instructions are like L L R L L R. Okay, so now this robot will first move to this point, right? After and then he will obey the second instruction. So now he will go to this point, then again the R, so he will come to this point again, then L, so he will go to this point again, then again L, so he will go to this point, and R, so he will come to this point again. Okay, let me draw this more clearly. So the movement of the robot is going to be like this, then this, then this, he will come again, then again this, then this thing and this, right? So in this, what if we have to find that if that robot has died or not? So we can see that there is some range in which this robot has moved, right? So like this robot has come on this coordinate, on this two, and this. So if there is some spike in this coordinate, somewhere between this coordinate, I know that the robot will die. Is that clear? So now I just have to find that if there is some spike in this, and then I will know that the the robot has died or not. So that's was it. But how? Okay, that was it, to find that if the robot has died or not. But how to find the exact time when robot has died? This is the interesting problem. Okay, you have to find that out the exact time when this robot has died. So in this, you know that in this the thing was about using binary search. So because you know that there will be some range for instruction. Okay, let's say we just have only this three instruction. Okay, we didn't have this three. So now L, L and R. So now my range is going to be like this thing. So if there is some spike in this range, then I know that my robot has died in this time interval only. He didn't even he didn't even see this instruction because he died before this. Okay, then let's say he did not died in this. So we see the whole range, and in the whole range, the range is something like this, right? The maximum left point he can go is this, maximum right he can go is this. And I will ask that, is there some spike in this? If there is, then we know that the robot has died in this time interval. Else, we know that the robot has not died yet. So that's all we have to do in the binary search. So now what we'll do is, for each interval, we will sorry, for each robot we have to find that when it has died. So is this clear? And to find this thing, we will use the binary search. The binary search. So let's say we have to find if it has died from the 0 to mid range. So if the robot has died in this time interval or not. So then I will check the maximum left and maximum right the robot can go. The robot can go. And then if there is some spike, then the robot died. Else, no. Else he is alive in this time interval. So that's it. Then what we'll do is we will just so now we know that let's assume the values are like this thing. Well, no. Let's say the time is like this. One, then the second instruction, third, fourth, and fifth. So now if I know that the robot died in this fourth instruction, then I know that the robot was alive in this first three. Then he will contribute in this first three. So I have to add one for all these first three elements. Like, can everyone understand this? So that's what I did. So what I do is, let's say from here, I take the input, the robot and the spike and the instruction, which is the HTR. Then I sort all the spikes in the increasing order, and this left and this right, this left and this right, they are the like the core of my code. Okay, what they are storing is that so the left of I will store that if I move, sorry, if I take k instructions, sorry, I instructions, then what is the maximum left I can go? And similarly, the right of I would be the maximum right I can go. Okay, and this is the way to compute it. I take the current position, the maximum left I can go, and the maximum R I can go. Then if the string is L, the current will go to left, and else it will go to right. Then the maximum R is the maximum R or current, and the maximum L is the max L or minus 1 into the current. Now why minus 1? Why minus 1? So let's see here. Let's say my current is equal to minus 3. Okay, I start from 0. And my current is equal to minus 3. Then I know that the max left I can go is equal to plus 3. That's it. So that's why I do minus 1 into the current and I store for all of the instruction. Okay. Now then the thing is to do the binary search. Okay. So this is the vector when die. It will store that which robot dies when. So like this was the, let's say this is the when die element for me. Sorry, when die array. And I know that the robot will die on this fourth element. Okay. So now I'll increment here 1. All of them will be still 0. And I will increment here 1. To be know that one robot has died in this fourth instruction. Okay. So that's what I do. And then I do just a binary search. What is the left range of the robot? So it will be robot of I minus the left the robot can go. The right range will be robot of I into the maximum right the robot can go. Then, so assume that this thing is L to R. Now I have to find that if some spike is there, in range L to R. Okay, that's I have to check this thing, so I just do lower bound on this spike from the left range, which will give me the value or the iterator greater than equal to left range. And now I will just iterator see if this value of this iterator is less than this right range. And if this is the case, okay, so now let's say if it is equal to spike dot end, so it means that there is no element which is greater than this left range. So I will just do that. No, the robot has not died currently. I have to go in the right. I have to go in the right range. Okay. Else, if the value of this iterator is less than the right range, less than equal to, I know that there is some spike which is greater than equal to L and less than equal to R, which is so I store this into answer and then go to the left part of the range. Else I just go to the right part. Okay. Now if the robot cannot die, I just put it in the last element. Okay. You can say this as the infinity or something. Or if the robot die, I will do when die answer plus plus. Then I just have to find the answer. So which is nothing but reversing a loop and having the number of current alive robots we have and adding this into when die and just printing this. So I guess that was it. The main core was using the binary search to use the to find when the robot died. So that was it in this question E. Now let we come to the question F, which is battle cows, which is the which was like one of my favorite questions from this contest. Okay. So let's read the question. Okay. No, I'm very lazy to read the question. Let's just see here. So in this question, like we will have some cows. The let's say the number of number of cows, but this thing will be the power of 2. Power of 2. So let's say we have n is equal to 8 in the starting order and we will have some elements. Elements are something like this. So, okay, let's just read the question. Yeah. This is the cow competing in somewhere and we have 2 raised to power n cows and ith cow has the skill level AI and there is the stack of cows. Stack is nothing but like the cows are in some group. Okay. And the skill level of the stack is equal to the XOR of all the cows in it. Huh. And for example, if the stack consists of cows 139, then their skill level is just XOR of this 3 element, which is 11. And what the process is happening, this is the main thing. Okay. So for every stack in the odd position, so 1 3 will start a fight with the stack to its right. So one will fight to the second, third will fight to the fourth, and so on. Now the stack with the higher skill level will win the match, and the winning stack will jump on the top of the losing stack. Okay, so let's see this by an example. So we have this 8 elements. So we have this 8 cows and all of the cows are alone in the starting. Okay, so this cow is like alone. Now this first cow will fight with this one, the second will fight with this, and so on. So what will happen? This let's say uh, these two cows will fight now. Who is going to win? Of course, the second cow because the value is more for the second cow. And if the second cow wins, the winner jumps on the losing stack. Okay. So the winning stack jumps on the top of the losing stack. So what will happen is that now this is 2 and on this 2, 5 will be here, okay, and now this is my one stack. This is my one new combined stack, okay. And what will be the power of this? What will be the skill of this? It is 5 XOR 2, which is 7, okay. Now this two will fight, this one will win, this will be in the top of this, and the skill of this could be 3. Then this 5 6 will fight, 6 will be in the top of the 5. The skill of this thing is going to be, I guess, 3. XOR of 6 and 5 yes, 3. And then the 7 and 4 will fight, and now their power is also 3. Okay, so now we have, in starting we have 8 stacks, now we have 4 stacks, and they will again fight. So now these two will fight and these two will fight. And what will happen from this is the stack of this thing will fight, and this stack is going to win because it have more skill. So this stack is going to be on top of this. So now stack is going to look like something like this. There is the 2 1 in the down and 5 2 on the top. And for this, we know that if tie happen, the left one wins. So left one is going to be in the top. Oh, sorry, like 7 and 4. And on the top of 3, this, that we have 6 and 5. And again, they will also have some XOR value. For this case, it will be 4. This case, it will be 0. And now this thing will win. And this thing will now be in the top of this thing. Okay. So that's how fights are happening. But to make this game more exciting, Farmer John created queue positions such that the ith position sets the skill level of cow, who drinks it to CI, and the Farmer Jones wants to test his poison on the cows, and so he gives the ith poison to cow BI and then runs the tournament. And for each trial, Farmer John wants to know how many cows are above the cow that was given the poison. So what will happen in this? So like the farmer will now choose some of the cows, any cows, like let's say this cow, and now he will give this cow poison, and let's say the skill level will now change somewhere to 6. So we know that now this XOR value will change, this XOR value will change, and the whole fight will change. Okay, whole scenario will change, and then we have to output that on this cow. How many cows are there on top of this? Okay, we have to give this. And there are Q queries, and the queries are till 1e5. So we have to give the answer in O of 1 or O of login. How we are gonna do it? So let's say I don't know much about this, but I just try to make a tree. Okay, tree for length 8. Let's try to make a tree for length 8. So in the first, the elements is going to be like this. Okay, 5 6 7 8. Now I know that these two will fight, and after that I will have the tree from 1 to 2. Let's just write this as 1 and 2. Okay, this will fight. Now they both will fight. 3 and 4. Now they both will fight. 5 and 6. Then they both will fight. 7 and 8. After that, what is going to happen is they both are going to fight. So now the array is going to be like 1 2 3 4 and 5 6 7 8. 5, 6, uh, and 5, 6, 7, 8. Is this correct? Like this stack will, like this both will now fight with each other, and in the last, I will have the big stack from 1 to 8, from 1 to 8, right? And there will be like the stack from 1 to 8, and the counts are going to be like somewhere shuffled. Okay, so now what if I change some like value of this fourth count? Which of the fights are going to be affected? This is the main question you have to ask, right? So if I give some position to this, means I update the value of this, which of the fights are going to be affected? Okay, so we know that of course this fight is going to be affected. Then this fight going to be affected, and then this this fight meaning the fight of this fight meaning the fight of this, and this fight meaning the child of this fight. Okay, so in this we know that it is the main observation. What is it? It's just that if I change some value, then it is going to be affect the number of fights which are the level of this tree. Okay, so I have currently this tree reversed, but the level of the tree, or you know that what will be how will be the level, right? So you can see that in the first thing it was 8 elements, then they reduced to they become half, then again divided by 2, and again divided by 2. So we know that effect no more than log n log n fights. So that's it. That's all we will do in our brute force approach. So like I just change the value of this 4. What will I do is I change this value fourth. I mean sorry. I the value of this fourth count. Then I just do this fight again, and again I just see that what is the Zor and who win. So after that I modify this value. After that I modify this value, and after that this value, and that's how I will know that how many, like what is the answer. Okay, but how do we find the number of counts on top of the ith count? How do we find this? So it's nothing hard, just a simple observations. Just assume that the elements are like 2 and 4, and this is one stack. The other stack is like 1 and 3. The XOR of this is 6. The XOR of this is 2. So I know that this thing is going to be win, and this thing is going to be on the top of this thing. Okay. So let's say the my cow is this one. Okay, first cow. I want to find the answer for this first cow. Okay, so I will know that when this stack which includes this first cow loses the match, there will be some cows will come top on this array. Let's see, what do I mean to say this? We have to find answer for this fourth. Okay, for this fourth. So assume that in this fight between 3 and 4, the fourth lost the match. I just stored the answer here. The fourth cow lost the match, so 3 will be on top of the 4. So I know that there is one cow which is on top of the 4. Then let's say that I do fight of this 2 element, and now this stack wins. So this stack is going to be on top of this. So I know nothing is going to be on top of 4 now. But now in this case, let's say the fight is between these two stacks and this one wins. So this whole stack is going to be in the top of this thing. Is that correct? Is going to be on the top of this thing. So I know that now the answer will be added by this 4. And that's it. When we are losing, we just add the size of the current element. And when we are winning, nothing to do. And that's how we find the answer. So this is only the thing. The observation is that the change some value will affect no more than log and fight. So we will just do the brute force. And we have to make some tree like this. Now this is some interesting approach. Okay, you have to you have to have a way. So there are many ways, multiple ways to do this. One way is the lead code way. Lead code way, you just have the struct node and store the value. In this we store the value lr. lr is just what range is he talking about, right? So in this case it will be l is equal to 1, r is equal to 4, and the zor of this is like a lead code way. The other thing I used which is faster than this to code is the segment tree way. Segment tree way. So like in we know that in the segment tree we have some arrays like this, and we know that the child of this node 1 is going to be 1 into 2, which is this, and 1 into 2 plus 1, which is this. So the child of 1 are these two. The child of this 3 is going to be 3 into 2, which is this 6, and this 7. That's how I just stored this tree. Well, this is currently the rotated tree. So this is the root. Okay, this is the root. Sorry, this thing is the root. I stored this thing. I think we just see the code so it will be more easy to you. Okay, so what do I do? I just take the answer n is equal to the 2 raised to power n. Okay, and then I take the input and I take the input in this, and now I make this segment tree way of answer. Well, answer is just the name. Okay, I will build the array. How will I build the array? What do I mean by building? I will build is just because for each element I have to store that what is the zor of it, right? So like I will for this one too I will ask for this child, and do the zor of this, and I will store at this point. Okay, then I will store the zor of this point, then I will store the zor of this, and that's it. This is just the pre-computing. So that's what I do in this find operation. In the find, I have given the left range, the left range, right range, the current node, the answer, and the ARR array. If we are at the leaf node, just store the value which is ARR of I minus 1. Remember that the ARR is 0 based, but the tree is 1 based. So you have to be careful in this point. Now, if it is not the tree, then I divide it in two parts and find the answer for these two parts, and the answer is just going to be zero of these two parts. That's it in the pre-computation. Now comes the main part. Okay, let me just remove this thing. I will do this q minus. So I traverse for all the queries. I take the index, the value, and I have, let's say I have a global value declared this ans ss here that will store the answer for this ith query. The answer is currently 0 in the starting, and I will check on this. Now comes the heart of my code. This is the checker function. Oh, sorry, check function. The name is just dumb one. So what we have to do in this? So if it's the leaf node, we will just return it. I know that there will no fight be happening. Else I will ask that thing that in which part my main count on for which I am thinking, right, the main count which is at the index I, in which part it is, in which child. Okay, so it's like if my child is like this, if my count is like this 4, and I am currently at here, I will ask that in which child this count is there, because I don't have to care for this one. I only care for the segment in which my cow is there. Okay, so first I will ask that thing. If int is less than this mid, I know that my cow is in the first range. For that I do range is equal to 1, and then calculate the answer only for this range, only for this child. I know that I don't have to find the answer for the other child. Okay, and if it's in the right part, I count this for the right part, and this is the thing. Okay, if the range is equal to 0, if the range is equal to 0, so let mean, what do I mean by this is, let's say I am in this segment. Now my child is in this path, so my range will be equal to 0. Now I will check this, the scale of this element and the scale of this element. Okay, so the scale of this element is temp, which is returned by this function, and the answer of this has already stored the scale of the rightmost part. Okay, and if the scale is greater than this, so I know that this temp has 1. So this stack would be in the down node for it. But if they have loses, then the answer would be increased by the size of the child. Okay, so if this thing loses, then answer will be increased by the size of this 4. That's it. And I just do increment, and if it is in the right case, I have this thing and return the skill, and that's it. I do. So that was the code. So I use this segmentary version of the tree to store the tree, which is the easier. And I guess that was it for this question. This was like pretty hard question, but the observation is very small. Is that the change does not affect no more than n log n fight, or more than log n fight. That was it. Then let's come to the last question of this, which is like the hardest question among of it. The question was of the permutation, combinatorics. So let's see the question. This is, hmm, this is the amazing question, and let's say what we are given is that we are given n different arrays, n arrays, and we can do some operation. Okay, some operation exactly once. So we will choose one array. Okay, I don't want to read this thing. In one operation, what we can do is that, so let's say we have some array, some of the arrays. Okay, some arrays are like 1, 2, 5, 4, then 3, 2, 1, then 1, 2, 4, 7, and something like this. Okay. Now what I can do is, I can take some element from some array, right? Let's say I take the third element from the first array, and then I will remove it from here, and then add it somewhere else in the back of the array, right? Somewhere else. And then after this, after this, my answer will be sum of MEX of all arrays. All arrays. That's it. So like in this case, the MEX will be 0, in this also 0. Let's say in this 0. Okay. Just a second. Okay. Now quite better. Okay. So MEX in this case would be 4. So like in this case, after I moved this 5 to here, the thing is going to be like 0, which is the MEX of first array, then 4, which is MEX of the second array, then 3 plus 3. That will be my answer. So this was the operations. And what we have to do is that we have to evaluate the sum of the values of all possible distinct independent operation. Now, okay, so now what do we mean by distinct independent operation and how many distinct operation will be there? And we need to find the sum of for all of them, right? Like let's say there can be many operation. Okay, let's see how many operation will there. So we take this 4 and add this in this one or this one or this one, or we take this, oh sorry, I will take this 5 and add in this array. I take this 2 and add in this. So there are like many possible moves. Okay, there are like many operations are going to be happen. But like what is the observation you can take in this? Well, just for 1 minute try to think, and I just drink the water for now. हाँ एक मिनट अच्छा तुम्हारी लेवा है तो और कहीं नहीं. Okay, so in this question we know that the many operations are going to happen, but can you see one observation? So like the operation are going to be like many more like this. We take this 4 and have here, we take this 5 and take it here or somewhere else. But you know that the change, okay, let what I want to say is that observation is that observation is that the change is of max is going to be happen in only two arrays, right? Only two arrays. So that's it. Because let's say like you have many more operation and you do, but okay, let's take any operation. Okay, let's take any operation. So some operation is like this to this. You take this two and put it here. So you know that the max of this value can be changed. Max of this MEX of this value can be changed, but all of the other, right? All of the other n minus 2 arrays, they will remain constant, or their max will remain constant. Okay, constant. That's it. So let we stop for a second and see that. Let me just move. Now I think we should move in this. Like, I'm sorry, we have to iterate on all of the elements. Okay, so let's say we iterate on this element, and now we will just calculate. What we will calculate in this is that what if for all operations I choose one of element from this and put it somewhere, one element from this and put it somewhere else, then what is the change in its MEX is going to happen, right? Can you understand me? Okay, so let's say this value is this thing. Okay, now I will come at this 0. I will come at this 0, and then I will ask to this 0 that If I remove this 0 from this element and I put it somewhere else, then, okay, let's say remove 0 from first array, then we know that then the max would be equal to 0. And how many ways I can remove this 0? So there are three ways. I take this 0, put it here, or I take this 0, put in the back of here, I take this 0 and put in the back of this array, right? So now I will have three ways that max will be equal to 1. Then what if I try to remove the 1? I remove this one. Then I know that my max would be 1. And for how many ways I can remove this one? So there are three ways. Or in particular, you can say n minus 1 ways. So the answer will be just plus equal to the max after removing current element into n minus 1 right? This was the thing. Okay, sorry, n minus 1. Okay, I think I just have to stop for a second. And what do I mean by doing all of this thing is observation is what we'll do is, okay, observation 2. Observation 2 is like for each array there are three cases have going to happen. Now what are these three cases? One case, the first case is there is some operation in which I take the element from this array. The second type of case is I take the element from some other array and put this element into this array, right? Like I take the element from other array and put it in current one. And the case 3 is going to be not affected by anything, right? So these are the three cases. So we will have to find the answer for all of these three cases. Okay, and currently we are thinking about this first case, which is this one. And you can see this thing easily, like what if I just remove some element and then the answer is just max after removing some element into n minus 1. So that was it for the case 1. Okay, that was it for the case 1. This thing was the case 1. Now let me talk about the case 2. What is this case 2 is that I take some element from other array and put it in the current one. Now what will happen in this? Let's just copy paste this thing. Let's just copy paste this thing here. Now like I am counting for this array, so I will count that what is going to be the max if I take some element from some other array and put it in the back of this one. Is that right? Okay, so what can be the different cases in this? So I know. So let's say currently the max is, what is the current max? 0, 1, 2, the max is 3. And the condition is if I get 3 from other array, like I just take this 3 and put it here in the back of this, now my array would be like this and the max is going to be 6. So just I need to find out this case, right? If I get 3 from other array, max is going to be 6. Sorry, there is no other case of this. Okay, there is no other case. Like the max of this array is not going to be affected by any other element. Okay, I take this one, put it here, doesn't matter. I take this two, doesn't matter. Only I put 3, then only the max will change. Okay, so these are the two cases in this one. Okay, so what I can do for this, I will just find that in the other n minus 1 array, how many elements are there? How many elements are 3? So there is only one element which is 3. So I know that there is one way that I put this 3 in this here and I will get the max is equal to 6. And all the other elements, this is 1, 2, 3, 4, 5, 6, 7, and 8. All the other elements, which are 8 ways, such that the max will not be affected and the max will remain a 3. So this was all about the case 2. Now talking about the case 3. Case 3, when nothing is affected. When nothing is affected. So you just have to find, the answer is just max into, sorry, the MEX into number of operations without that doesn't include this array, this ith array. Okay, so now let's say how we are going to find this thing, how we are going to find it. So let me try to find for this array. Okay, so now we have to find the number of operation that doesn't affect this array. So there is no element which is taken out from this, or there is no element which we put into this array. Okay, so now you can think that this array does not exist. The operation are just going on to this 3 element. So you know that for each element there are n minus 2 ways now. Okay, because this array does not exist. So for this element you can take and put it, there are 2 options. For this element also 2 options, this element also 2 options, this element also 2 options. So there are going to be remaining element into what? N minus 2. This much way, we can do the operation, right? So this much way, so this is going to be max into remaining elements into n minus 2. That's it. So that was all this thing. And now, like, this was a pretty hard question, but just if we go the observation by observation, this is going to be very, very easy. Now let's just see the code for it. Okay, trust me, it's not that tough. The code is not that tough. What I do, I take the array, I take the input. I have two maps. So this frequency is like the global frequency. Okay, so this is like this frequency of something. Okay, let's say frequency of fr of 1 will just say me that in all of this array, how many times 1 has come. Okay, that's why I use this fr. And this fr2 is a pair. Fr2 is a pair in which the elements will be like the ith array and the element. So with the use of fr2, I can ask that in some particular array, how many elements of some value are there. Okay, that's why there are two different maps. Now what I do, I just take the input and just updated the value in the map, and this is the thing. So for each array, I have to count that what are the two max values I will have. So let's say the first is mx1 and second is mx2, and that's how I find the value. This is nothing but I just have run a loop on this. So it's like the elements are like something like this. My current will be 0 if there is 0 in the array, my current would be 1. Then 1 is there, my current would be 2. 2 is not in the array, so mx1 would be current. Then current would be just plus plus, current would be 3, then 4, then 5, and then in this case the 6. So mx2 will be the 6. Okay, so that's how I find the first two MEX the array can have. And then answer plus equal to mx2 into this thing. Okay, so in this case we are talking about case 2, which was the case 2, the second case of the observation 2, sorry. Okay, this is the case 2, and we just as we talked about that if we get some required element, then the max MEX would be increased. Okay, that's what I do. MX2 into the number of elements of MX1. So what do I mean by this is that if the array is like 0, 1, 2, 4, 5, 6, 4, 5, then if I have 3 from some other element and put it here, put it here, then my MEX is going to be MEX MX2, right? So this is just MX2 into the frequency of mx1, which is 3 in this test case. Okay, then this is this case. Okay, if I get 3 from other, then max is equal to, and for all the other ways, sorry, mex is going to be mx1. So that's it. I just find that how many other elements are remaining. So I just find the total elements minus the elements that are of type fr of mx1 minus the elements from this first array of ith array, sorry, and then for this mx1 into the remaining. So this was all about case 2. Now this thing is case 3. Case 3. Now in this the answer is just mx1 into tot minus remaining element into n minus 2 as we talked here. Is this clear? Now comes the slightly confusing part, which is this one. So this is the case 1. This is the case 1. So in the case 1, what I do is that this is the case 1. Either remove the ith element and then say that what is the MEX is going to be, and then answer is just MEX after removing this element into n minus 1. So that's it. So if FR2, like if the frequency of this ith element is more than 1, then of course I know that nothing is going to be affected. There are more frequencies of this. Then answer is then the MEX is just be MX1. Else answer will be the MEX is now going to be minimum of this element and L MX1 into L minus 1. So that's it. That was the case 1. And you just for all of the array, you just find this thing. For all of the array, you find this thing and output the answer. So that was it in this question. Like I know this was pretty hard to see, but this in this you just have to keep taking some observation. First observation we take is that there are 3 cases, and then we found the answer for all of the 3 cases independently, right? That's how we did it. So okay, that was it in this question, and we have solved all of the question now. So that was it for now. If you have any doubt, or if like there is any question which you can't understand, you can write it in the live chat. Okay, so like how, like just comment guys, like how was my explanation skill? Like are you satisfied with it or not? Or in which section I have to work on?